Hello and welcome to a screencast about the factored form of a quadratic function. And this form is called many different things. So I've heard it called factored form, I've heard it called intercept form, heard it called lots of different things. So this was a thing that was in our previous properties video, but I wanted to make sure that we refresh ourselves of what this says. So in general, if we know the x-intercepts of quadratic function, or the zeros, they're also called zeros, and if we know that they are r comma 0 and s comma 0, it follows that we can write the quadratic function in the factored form q of x equals a times x minus r times x minus s. All right, again, we have a parabola kind of floating off here in space. So I want to figure out what the equation is in factored form. And you might be asking, I like that vertex form, so why can't I use that? Well, you could, but on this particular problem, is it very easy to eyeball where that vertex is at? No, I don't think so. It's kind of floating off here, and you would definitely have to approximate it, so you couldn't find an equation exactly. But factored form means that we need to know where our x-intercepts are. Okay, and those certainly are at nice points. So if you look over here on the right, I see a 0 x-intercept at 2, 0, and I see another one over here at negative 5, 0. Okay, so using those in our form up here, again, we don't know what a is, but we can find it. So let's leave that one alone. So a times x, and again, these have these negatives built in here with the x's. So remember, that means you're going to have to be switching our signs. So x minus a minus 5, so that's going to end up being x plus 5, and then x minus 2. And again, these make sense because if you were to set these factors individually equal to 0, you're going to end up with those x-intercepts. Okay, so that's always kind of a way you can double check yourself. I know sometimes changing signs just gets confusing. All right, so now we've got to deal with this a value. So how do we do that? Well, again, we want to eyeball, so let's find another point on this parabola. We already said the vertex was out because that was kind of at a wacky point. There's actually quite a few of them. Again, I like to try to use the y-intercept if possible because I like plugging in zeros for x's if I can. And I believe this is a nice point. So this is 0 comma negative 5. That's my x, that's my y, or my q of x in this case. So let's plug that in. So negative 5 equals, a is what we don't know, that's what we're trying to find. 0 plus 5 and 0 minus 2. Okay, crank this baby out. So we get a times 0 plus 5 is 5, 0 minus 2 is negative 2, so that gives us a negative 10. So divide both sides by negative 10. Our a gives us a half. Oops, no, it should be a 2 there. Okay, so maybe that's why we didn't end up with a nice value for our vertex. Well, but that necessarily is not the case. But yeah, so anyway, we didn't end up with a nice value for our vertex. That's why we've got another form to work with. So q of x is 1/2 times the quantity x plus 5 times x minus 2. So that would end up being our equation of this particular parabola. So again, I recommend putting this into Desmos or your favorite graphing utility, graph it, and make sure it actually matches the graph that is shown here. Great. Thank you for watching.